Suppose that the position of a vertical projectile on planet X is given by S of t equals 36t minus 12t squared. Find the total time that the object is in the air and find its velocity when its height is 24 feet and falling. Okay, so to find the total time that the object is in the air, we want to know when it lands. So the object lands when the position is equal to 0. So we're given the position function, that's the height function, and that's 36t minus 12t squared is equal to 0. We could factor out a 12t, and we're left with 3 minus t. And so if 12t is 0, then t is 0. And if 3 minus t is 0, then t is 3 seconds. So there are two times when the object was on the ground. Time 0, that's when it was launched. At time 0, the height was 0. And at time 3 seconds, so that must be when it landed. So the object was in the air for 3 seconds. Now we want to know how fast was it going when it was 24 feet in the air. So presumably it reached that height and falling. So here's the ground. The object went up and then fell. And at some point it must have been 24 feet, or we'll discover that it was 24 feet in the air. And we want to know how fast it was going. What was its velocity when it was falling? So when was the object 24 feet in the air? If it was ever 24 feet in the air, there might be two different times. So we'll take S of t and we'll set it equal to 24 and we'll solve for the time. So that gives us 36t minus 12t squared is equal to 24. If I divide everything by negative 12, I get negative 3t plus t squared is equal to negative 2. And then putting all the terms on the left side, we get a quadratic equation, t squared minus 3t plus 2 is equal to 0. We can factor t minus 1 times t minus 2 is equal to 0. So t is 1 or 2 seconds. So it appears that the object was at the height 24 feet twice, once after 1 second, and then again after 2 seconds. The later time must be when it was falling, because the object clearly rises first and then falls. So after 1 second, it must still be rising, and then after 2 seconds, it's falling. So the answer to our problem is the velocity at time 2 seconds. And just for fun, we'll also find the velocity at time 1 second, because they're going to be related. But in order to find the velocity at any time, we need the velocity function, which is the derivative of the position function. And here's our position function. Its derivative is 36 minus 24t. So if we plug in 1, that would give us the velocity when it was 24 feet in the air and rising. And that would be 36 minus 24 times 1, and that's 12 feet per second. And then if we plug in 2 for time, we get 36 minus 24 times 2 is 48. And this is negative 12 feet per second. So the negative is telling us indeed that the object was falling. The speed is 12 feet per second. Notice on the way up and on the way down at the height 24 feet, the speed is the same, 12 feet per second. The only difference is, of course, the direction. So the velocity was negative 12 feet per second. The velocity includes the direction.